Hi class, in this lecture I want to talk about another counting method called combinations. So it's going to be a lot like the permutations calculations that we saw in the previous section. The only difference here is that the order is not going to matter. So the order that you select or the order that you um, uh, either select or arrange things doesn't matter. Also have your graphing calculator handy as we do these problems because I'll show you how to use your graphing calculator to do them instead of doing them by hand. Okay, so our first objective is distinguish between a permutation and combination problem, and then we want to solve problems involving combinations using the combinations formula. Okay, so a combination of items occurs when items are selected from the same group. Again, no item is used more than once, just like with permutations. And here the order of items makes no difference. So the order you select them, arrange them does not matter, no difference. So permutations involve situations or problems in which order matters, right? Combinations involve situations or problems in which the order of the items makes no difference. So permutation order matters, combinations order doesn't matter. Okay, so let's determine the following if there are permutations or combinations. So 6 students are running for student government, president, vice president, and treasurer. Okay, so we have 6 students. We want to, have select 3 of them. The students with the greatest number of votes become the president. The second highest vote getter becomes vice president, and the student who gets the third largest number of votes will be the treasurer. How many different outcomes are possible? Well, here the order matters since the number of the 3 highest votes determine the office. So this is a permutations problem. Okay, so it would be 6 pick 3, right, or 6 permutations of 3. All right, 6 people are on the board of supervisors for your neighborhood park. A 3-person committee is needed to study the possibility of expanding the park. How many different committees could be formed from the 6 people? Well, the order in which the 3 people are selected doesn't matter since they are not filling different roles. So if you're selected first or third, you are still on the committee. So this is a combinations problem. Order doesn't matter here. Okay, let's do some examples. All right, or just seeing the difference here. So given the letters A, B, C, and D, we can compare how many permutations and how many combinations are possible if we choose 3 letters at a time. So what you're seeing here, this column contains only one combination, okay, because they all contain the letters A, B, C, all right? So in terms of combination, this would only be one combination, right? This column contains another combination of just the letters A, B, D, so the order doesn't matter here, right? So instead of being, well, there's 6 different ways to arrange A, B, D, we just say there's one way to select the letters A, B, D. You can see the same with C, D, C, A, C, D, and B, C, D. Okay, so combinations are going to be, the number of combinations are going to be a lot less than the number of permutations. All right, so the number of possible combinations, the formula for it, if R items are taken from N, so like 10, the way we would read it, if there were 10 items and we wanted to find the number of combinations with 4, let's say, it would be 10 combinations of 4. Now it's n factorial divided by n minus r factorial, which we've seen before, but we're also going to have this extra r factorial in the denominator. Okay, so let's do some examples. How many 3-person committees could be formed from 8 people? So we're selecting 3 people from 8. Well, just using your formula here, this would be 8 choose 3, or 8 factorial divided by 8 minus 3 factorial times 3 factorial, which ends up getting 8 factorial divided by 5 factorial times 3 factorial. Now you can go through and try to do this by hand, but what I want to do is I want to show you with your graphing calculator how you can do this very, very easily. So I want to find with our graphing calculator 8 choose 3. Well, if you press the math button, go over to PRB. We've seen the NPR, we've seen the factorial. Now we want to do the N choose R. Well, this would be 8 choose 3. So it's option number 3 here. So what you're going to do is you're going to type the first number to begin, the 8. You're going to hit math. You're going to go over to PRB. You're going to go down to the NCR. And then you're going to type how many you want to choose, which would be 3. And look, 56. Same thing we get if you were to do this by hand. All right, so, you can, whenever you want to do, like if you had 40 things and you wanted to choose, I don't know, 4 of them, whatever, doesn't matter. You can just plug it in your calculator that way. Okay, let's do another one. So in December 2011, the US Senate consisted of 51 Democrats and 47 Republicans with 2 independents. How many distinct 5-person committees can be formed if each committee must have 3 Democrats and 2 Republicans? Okay, so this one's a little bit harder, all right? So here's what I have. I have 5-person committee. It must be the 3 Democrats and 2 Republicans. Okay, the order in which members are selected does not matter, so the problem here is a combinations problem. So the first thing we have to do is we have to pick the 3 Democrats from the 51. Well, how are we going to do that? Well, that's NCR. Okay, so that's the 51 Democrats, and I want to choose 3 of them. Okay, because I have 3 objects, 3 people out of 51, so it's an N and R problem. So this is just a combination, and you get 20,825 different ways you could choose 3 Democrats from 51 Republicans, or 3 Democrats from the 51 Democrats, excuse me. All right, but now we need to do the 2 Republicans. Okay, so it's the same thing, but it's 47 choose 2. There's 1,081 ways you could do this. All right, so then now to find the total number of ways, we have to use the fundamental counting principle, all right, to find the total number of committees that could be formed. So it's the number of ways you could pick the Democrats times the number of ways you could pick the Republicans. And this would be 22,511,825 different ways. All right, so I encourage you to make sure you use your calculator for these problems.